Hey guys, it's STEM with Sid, and today I will be talking about the chain rule. The chain rule is just taking the derivative of functions that have functions, well, inside them. So it's like you're kind of taking a derivative of like a more complex type of function, and it's to do it, you have to take the derivative of the outer and then multiply it by the derivative of the inner, and then keep doing it until you're done with the derivatives. So like if you have, for example, dy dx, that is simply equal to dy du times du dx. Du being a function inside. Okay, so you do the outer function, well, let's say that's dy du, and then you multiply that by the inner function du dx. The easiest way I can teach this is by simply doing example problems. So let me get out some example problems for me to go over. So you have y equals x squared plus 1 cubed. Y prime will be 3 times x squared plus, because you just, move it down, right? 3x squared plus 1, and then reduce the power by 1. Multiplied by the inner function, this x squared plus 1, the derivative of that is just 2x. And then there's no more inner functions beneath this. If the x had something like 2x plus 5, then you have to take the derivative of that. But you don't have to do that here. So this is the derivative. You can multiply this out, but you get 6x times x squared plus 1 squared. Let's do another example. I have one where it's another one that applies the chain rule here, where it's f of x equals cube root of x squared minus 1 squared. And the f prime of x equals, so this is 1/3 power, right? Or actually 2/3 power, because this 1/3 goes in the 2. So it's x squared minus 1 to the 2/3 power. Outer function, you put the 2/3 down, then x squared minus 1 to the negative 1/3 power, right? You just subtract 1 to 2/3. And then you multiply by the inner function. Inner derivative is 2x. Cool? So you just multiply, and you multiply that out. This x squared minus 1, the cube root of x squared minus 1 goes on the bottom. But yeah, you just multiply that out. Let's do another example where we have g of t equals negative 7 over 2t minus 3 squared. Derivative of this is simply, you can write it, by the way, you don't need to use quotient rule or anything like that. Just write it easier. So negative 7, 2t minus 3 to the negative 2. And derivative of this, you just multiply the negative 2 out. So you have, well, positive 14. Or I'll just write it like this. You have negative 7, you pull the negative 2 down, and then your 2t minus 3 goes down by 1. So instead of negative 2, it becomes negative 3. Then multiplied by the inner derivative, which is just 2. So that's for that example. Here, let's do another example. Basically, the derivative of the outer times inner. So f of x, another example, x squared times the square root of 1 minus x squared. For this, for this one, you would have to use the product rule in this, and then the power rule. So you can make this x squared times 1 minus x squared to the 1/2. Then you can use power rule for this. So you have, and then as you can see, you're not using power rule with x, you're using power rule with 1 minus x squared. So at the end, you would just multiply by the derivative of negative x squared, or 1 minus x squared, which is just negative 2x. So I won't do all the work here, but you would just do product rule with these two. And then when you're done with that, you would multiply by the, once you do product rule, you use the power rule, of course, for the inner function. So you're basically applying chain rule. And let's do one last example with normal functions. Then I'll try one with trig. So we have 3x minus 1 over x squared plus 3 squared, calling this y. Y prime just becomes, you move, the outer function is the 2. So you do the 2, then 3x minus 1 over x squared plus 3 to the first power. Then you multiply by the derivative of the inner function, which is 3x minus 1 over x squared plus 3. Guess what? You take the derivative using quotient rule. And then you have the outer function multiplied by the derivative of the inner function. Okay, now for some trig ones. Trig ones are also pretty simple. The outer function, usually trig, I'll show you an example. If you have y equals tan 3x, the derivative becomes 3 times the derivative of tan. Tan, the derivative of tan is secant. So it's secant squared 3x. So derivative is 3 secant squared 3x. And let's do one where we combine, where we have sine, or f of t, equals sine cubed 4t. Now, outer function, if it's not obvious, it's the cube. The sine is being cubed, so sine is inside the cube. So to take the prime, or the derivative, sorry, f prime t, the derivative is, first you pull down the 3. Basically, it's just, first, it's just really power rule, right? 3 sine squared 4t. Then multiplied by the derivative of the inner function. Now, inner function, you might think it's 4t. Yes, but that's 4t is the inner function of sine. And sine is the inner function of the 3. So you first have to multiply by the derivative of sine, which is cosine 4t. Then we multiply by the derivative of 4t, which is 4. So we have to apply chain rule for a bit more steps. Multiply this out, and you get the derivative. And you can simply use these, and once you get a full-on derivative, you can use it to find, like, tangent lines because, well, this is the slope of the line, and at a point, let's say you're finding at t equals 1, you can just plug in t equals 1 here, and you can figure out the slope at t equals 1. If you're given a point, 1, 1, or whatever, and you're given a derivative graph, and you can just plug in the point, figure out the slope, then you can just use y minus y1, if we call this x1, call this y1, equals, and then we call this m. Let's call this m. F prime 1 is m. X minus x1. So you just need a point and a slope at that point to get the equation. And, well, the slope is just the derivative, which you can even use chain rule for this problem to get. Well, that's it for this video. Thank you for watching. I'll see you next time.